In this video, I will show you how to make this bike handle and an easy assembly with the grips. At first glance, the modeling seems simple, but don't be fooled. It's actually more complex. I've made a short animation to show you why. The main operation we're going to use is an additive pipe for the long tube and a pad extrusion for the center tube. The tricky part comes from defining the path for this operation. As you can see, the handlebar has a back sweep. This means the path doesn't lie on a single plane, which is what creates the challenge here. I briefly mentioned this issue in one of my previous videos, but that video wasn't very informative and it went too fast to properly explain how to create this model. This time we're going to take the time to go through everything clearly, and I'll show you several different methods. If you are interested in the 3D model or the sketches to follow along with the tutorial, you can download them for free using the link in the description. And don't forget, you can leave a donation too if you want to support the channel. To start this model, as is often the case, we'll click on the empty file icon to begin with a blank page. To create this path, which isn't on a single plane, we're going to use two sketches. The first one, shown here on the left, represents the front view of the path. Since we're not cavemen, we'll model only half of it. The other half will be created using a mirror operation. The second sketch on the right corresponds to the top view, and it's what defines the back sweep. The goal here is to combine these two sketches to get a 3D path, almost like they had a baby together. To create this monstrosity, we're going to switch to the Sketcher workbench. To do that, go to the drop-down menu and select Sketcher. We'll start by creating the sketch that represents the front view. To do that, click on the Create Sketch tool in the toolbar. In the pop-up window that appears, FreeCAD asks us to choose a sketch orientation. Since we want to create a front sketch, we can choose either the XZ plane or the YZ plane. The XY plane corresponds to a top view, which is definitely not what we want. Here I'm going to select the XZ plane and then click OK to start sketching. The view automatically adjusts to place you perpendicular to the XZ plane to make sketching easier for you. To create our sketch, we're only going to use one tool, the polyline, which is extremely powerful. It's basically the Mewtwo of sketching tools. With it, we'll be able to create multiple segments with different shapes. Go ahead and select it from the toolbar. Place the first point on the origin of the axis. You should see the coincidence constraint appear as a small cross. When it shows up, click to place the point. Then move to the right to draw a horizontal line. You should also see the horizontal constraint appear, and then place the second point. On the sketch I showed you at the beginning, you can see that there's an arc in this area. To create it automatically using the polyline tool, we need to press the M key 3 times to switch to the arc mode. You can then place a third point. The great thing is that the tangency constraint is automatically created between the arc and the lines around it. Create a fourth point to finish the rising line. At this intersection, we need to create another arc. If you paid attention the first time, this should be a piece of cake. Press the M key 3 times, then place the fifth point. Finally, finish the sketch by placing a sixth point anywhere you like. To stop using the tool, right-click or press Escape, otherwise you'll end up with a mama's boy that won't let go of the cord. Great, we have the shape, but it's not constrained at all. To fix that, we're going to use the Dimension tool. By the way, doesn't this tool look like the big eye that the physics teachers draw on their diagrams to explain distance calculations? Or was I the only one traumatized by that? Anyway, select the tool, then create a horizontal dimension between the rightmost point and the green axis, and set it to 370 millimeters. For the same point, also create a vertical dimension relative to the red axis, and set it to 240 millimeters. Now we're going to define the upsweep, which is the angle between the top straight line and the red axis. We'll set it to 3 degrees. Don't mind the angle notation, it's trying to be fancy and went off to the other side of the map. Still using the Dimension tool, we'll set the radius of the top arc to 70 millimeters, and for the bottom arc, we'll set it to 55 millimeters. Next, we'll set an angle between the straight line and the red axis and give it a value of 67 degrees. Then we'll finish by setting a horizontal dimension of 30 millimeters for the small line at the bottom. You can right-click to stop using the tool. Now let's go find our dimension that ran away, just like Michael Scofield escaping from Prison Break, and bring it back closer to our sketch. Everything is green, which means our sketch is fully constrained. We can now exit it by clicking the Close button. Next, to keep our file organized, go to the tree view, select the sketch, and press F2 to rename it to Front. Now we'll create the second sketch, which is the top view. We'll use the same method. Start by clicking the Create a New Sketch tool in the toolbar. This time, in the window that opens, keep the XY plane selected because we want our sketch on the top plane. Then click OK. Here we need to be very careful where we place our sketch, because it has to be perfectly aligned with the previous one. The starting point is easy to find since it matches the origin, but the ending point is not. By default, FreeCAD turns on the Section View tool, which hides objects that might get in the way. But here we need to see the previous sketch, so click the Section View tool in the top menu to turn it off. You should now see the previous sketch in the viewport. Rotate the view a little and locate the point on the far right. We needed to constrain our sketch. To do that, select the Geometry Projection tool, then click the point on the far right of the previous sketch. You should now see a purple point on the red axis. That's the projected point. Next, realign the view by clicking top on the navigation cube, then click the Section View tool again to hide the previous sketch. Just like the previous one, we'll use the Polyline tool to draw our sketch. Start by clicking once on the origin. Then draw a horizontal line along the red axis and place a second point. I don't know if you remember, but there should be an arc here. Press M 3 times to activate the arc tool, then place the third point. Finally, create one last point below the purple point and right-click to stop using the tool. Now let's constrain the sketch. Select the Dimension tool, create the back sweep angle between the red axis and the line on the right, and set it to 5 degrees. Next, set a horizontal length for the line on the far left and make it 170 mm. Still using the Dimension tool, set a radius of 700 mm for the arc. The only thing left to fully constrain the sketch is to align the point on the far right with the purple point. Select both points, then use the Vertical Constraint tool to align them. This fully constrains the sketch, so we can now exit it. To keep the file organized, go to the Tree View and press F2 to rename the sketch to Top. Now we'll create our 3D path by combining the two sketches. I'll show you two methods so you can choose the one that works best for you. For the first method, we need to go to the Part workbench. To do this, select Part from the Workbench drop-down menu. Let's start by creating a new folder to group our sketches. This makes it easier to access them when used in operations, without having to expand all the operations to find the sketches. Select the two sketches, then drag and drop them into the new folder. To get the intersection between the two curves, we'll extrude each one along its sketch plane. Start by selecting the front sketch, then click the Extrude tool. In the window that opens on the right, set length along to a large value like 300, check the symmetric box and click OK to confirm. We'll do the exact same thing for the top sketch. Select it, then click the Extrude tool. In the menu on the right, enter a value of 500. Make sure Symmetric is checked and click OK to confirm. The goal here is to get the intersection between the two surfaces to create our 3D path. And you'll see it's very simple. Hold Ctrl, select both extrudes, then click the Section tool in the toolbar. You should now see only the curve on the screen, and you can check that it properly combines both sketches. This method is really the basic way to get 3D sketches in FreeCAD. To keep my file organized, I'll move it into my Sketches folder. Now I'll show you a second method, which I think is more elegant. And it requires fewer steps, because this is a bit like using a rock to hammer a nail with lots of steps, while a hammer would do the job much better. For this second method, we'll use an add-on that isn't installed by default in FreeCAD, and I think it should be. It's called the Curve Workbench. To install it, go to the Tools menu and click on Add-on Manager. In the search field, type Curve, then scroll down and click on Curves Workbench. Then click Install. Close the window and FreeCAD will ask you to restart to install the workbench. You can click Restart Now. FreeCAD is so great that it asks us to save before restarting, which could have been disastrous if it had closed without saving. So choose a location to save your file, give it the original name like Bike Handlebar and click Save. FreeCAD will restart and bring you to the home page. You should see your file in Recent Files. Click on it to open. Now, when you open the Workbench drop-down menu, you should see the Curves Workbench. Click on it to access it. The tool we need here to project the sketches onto each other and get our 3D path is the Mixed Curve tool. To use it, hold Ctrl, select both sketches and then click the tool. In the viewport, you should see the mixed curve appear. It's the same result as the first method, but here we didn't need to extrude the sketches. In the Tree View, drag and drop the mixed curve into the Sketches folder to keep the file organized. We can rotate the view a little to see that this curve isn't on the same plane. You can also make the section from the first method visible to check that they match. Both methods give good results, but I recommend using the second method, the mixed curve. It saves time and you don't need to use any extrusion operations. From here we can return to the classic modeling workflow by going to the Part Design workbench via the drop-down menu. In this workbench, we'll create the additive pipe. This operation consists of extruding a profile along a path. For now, we only have the path, so we'll draw the profile. Here you can choose either the section or the mixed curve for the path to follow, it doesn't matter. I'll hide the mixed curve and make the section visible. Since we are creating a new solid, we first need to create a body. To do this, click the Create a New Body icon. With the F2 key, we can rename it to Long Tube. It will help to clearly identify the body. Since we did things properly and our path starts at the origin, we can create the profile directly on the YZ plane. To do this, click the Create Sketch icon, then select the YZ plane in the viewport. The profile is very simple, it's just a circle with a thickness. To do this, use the Circle tool from the menu, create a circle exactly at the origin, and set its diameter to 21 mm. Still using the Circle tool, draw a concentric circle, that is with the same origin, and set its diameter to 17 mm. Then you can exit the sketch. Now we have all the ingredients to cook our delicious meal. However, the path isn't in our body, so we need to import it. For that, we'll use our good friend the binder. In the tree view, select the section object, then click the binder tool. You should now see the binder appear inside the long tube object. By hiding the section object, you should see the path in yellow in the viewport. This is the binder. Now select Sketch 2 in the tree view, then click the Additive Pipe tool in the toolbar. In the menu on the right, under Path to sweep along, click Object and select the binder in the tree view. In the viewport, you should see the operation preview appear in green. Everything looks good, so we can confirm the operation by clicking OK. For now, our handlebar doesn't look dashing because half is missing. To fix this, select our body in the tree view, then use the mirror tool to create the missing part. In the menu on the right, under the plane parameter, select the YZ plane. If you are confused, the easiest way is to look at the navigation cube to identify the axis. Blue for Z, green for Y, and red for X. So here we can see that the YZ plane is the correct choice. Super! Now our main tube is done. Next we need to make the middle tube. Before that, let's rotate our tube a little to see that it's not all on the same plane. Looking from the top view, we can clearly see the back sweep, which is exactly what we want. To create the middle tube, we need to create a new body. To do this, click the Create a New Body icon in the toolbar. Press F2 to rename the body into Small Tube. Since it's just a straight tube, there's nothing complicated. We'll start by creating the tube's profile by clicking the Sketch icon, then choosing the YZ plane as the sketch plane. Just like for the other tube, we'll use the Circle tool to draw the profile. Place the circle on the green axis and set its diameter to 18 mm. Then create a second concentric circle and set its diameter to 14 mm. Next, select the Dimension tool and set a vertical distance between the center of the circles and the red axis and give a value of 165 mm. Then you can exit the sketch. The goal now is to extrude this small tube until it reaches the long tube. To do that, we need to import the long tube into the small one. Select the long tube in the tree view, then use the binder tool. You can then hide it, and you should see the binder appear in yellow in the viewport. Next, select Sketch 3, and in the menu on the right, click the Pad tool. In the type parameter, choose Up to Face, then click the left face of the binder. Right now it only creates half, so to make it symmetric, go to the Mode parameter and set it to Symmetric. You should now see in the viewport that the tube has been created correctly. In the tree view, you can then hide the binder and make the long tube visible again to get a full preview of the handlebar. If later we want to use this handlebar in an assembly, since it's made of two solids, we need to create a part object. To do this, click the New Part icon in the top toolbar. This object works like a container to store all our solids inside. You can press F2 to rename it handlebar, then just drag and drop all our objects into this container. Now you should have a clean and well-organized file ready to be used later in an assembly. Before we continue, I want to take a moment to thank you, and especially the members of the channel who can drop their little caveman emoji in the comments, and also everyone who downloads the files and leaves a donation. Thank you from the bottom of my heart. Your support is priceless. As a little bonus, I'm going to show you how to create grips and assemble them on the handlebar, so you really get your money's worth. To do this, we'll create a new file. Go to File menu, then click New Document. These grips won't exactly break 3 legs on a duck, as we say in France, but at least they will exist. Making them will be very simple, just a simple revolution followed by an array. To start, create a new sketch and choose the XZ plane as the sketch plane. The goal is to recreate this sketch, nothing too fancy. To do this, we'll use the heavy artillery, the polyline tool. I want to speed up the drawing a bit. We're just recreating the shape with straight lines, so make sure to add horizontal and vertical constraints. You can slow down the video if needed using the player options. But at this point in the video, those of you who are still watching are the cream of the crop, so I don't think the drawing will be too difficult, especially if you've made it this far. To constrain the sketch, we'll use the Dimension tool. Start by setting a horizontal value for the point on the far right and give a dimension of 140 mm. Then, for the small vertical line inside, set the value to half the diameter of the handlebar tube, which is 10.5 mm. Next, set a thickness of 3 mm for the grip at the right end. Also set 3 mm thickness between the two long lines. On the left, set a thickness of 5 mm. For the highest point on the left, set a height of 25 mm. You can then exit the sketch. To make the revolution, click the Revolve tool in the menu on the right. By default, FreeCAD revolves along the Z-axis, which is completely wrong in our case. Here go to Axis and choose the base X-axis as the axis of revolution, then click OK to confirm. We now have the basic shape of our grip. We'll add fillets on the two right edges. Hold Ctrl, select the two edges, then click the Fillet tool on the right. You can leave the fillet size at 1 mm, then click OK to confirm. Now we'll create the small ribs. To do this, create a sketch on the extreme face of the grip. Select the face, then click the Sketch tool. Using the Circle tool, draw a circle with its center at the origin and set its diameter to 31 mm. If we leave the sketch like this, it would fill the inner hole, which is not what we want. To fix this, use the Projection tool to project the inner circle. The projected circle appears as a construction line. Select it, then use the Construction tool to convert it into a solid line. With Sketch 1 selected, then use the Pad tool in the menu on the right. In the parameters, check the reverse box so the operation goes in the right direction. Set the length to 2 mm, then click OK to confirm the operation. Now we'll create an array of this extrusion. In the tree view, select the pad operation, then click the linear pattern tool. In the menu on the right, change the direction to follow the base X-axis. Click the arrows to reverse the array direction. Then set the length to 135 mm. We can see that the last rib is misplaced, so subtract 2 mm to place it correctly. Next, set the number of occurrences to 35. You can then confirm the creation by clicking OK. We've finished modeling the grip. To keep our work organized and clear, press F2 to rename the body and call it grip. To be able to use this grip in an assembly, we need to save it. So hit your best Ctrl S, give your file a name and save it. Now we'll work on the assembly. We could have created the parts and the assembly in the same file, but since these are parts I might use in other assemblies, I've separated the parts into different files. We'll do the same for the assembly. To start, go to the File menu, then create a new document. To create the assembly, we'll go to the drop-down menu and then click on Assembly. Next, we need to click on the new assembly icon to activate the workbench. To import new parts into the assembly, go to the right-hand menu and then click on Component. The order in which you import your parts is very important. The first part you import can be fixed, meaning it won't be able to move. In our case, it's a static assembly, so it doesn't matter much. I still recommend importing the main part that won't move first. In our case, that's the handlebar. When you import the first part, FreeCAD will ask you to save your file, so go ahead and do it. Name your file Assembly. In my case, I'm going to overwrite the previous file I created to prepare the tutorial. FreeCAD will now ask if you want to ground the first part. In our case, we'll answer yes because we want our handlebar to be fixed. Next, we'll go back to the right-hand menu, scroll to the top of the list and click on the body grip. With the gizmo, we can move it upward to get a better view of the model. And finally, we can click OK to complete the import. The goal now is to attach the inner face of the grip to the outer face of the handlebar. To do this, we'll use the most basic join, which will fix the grip in both translation and rotation. Click on the Fixed Join icon in the toolbar. In the viewport, select the innermost face of the grip and then the outermost face of the handlebar. It's crucial that the gizmos are oriented the same way. Once you've selected the faces, the grip should automatically move into the correct position on the handlebar. You can then click OK to confirm the placement. Since this is a dynamic assembly, we can go to the tree view, open the handlebar part, go into the Sketch folder and double-click on Sketch Front to edit it. Here we'll change the value 370 to 380 mm, then close the sketch. In the viewport, we can see that the grip's position has updated automatically without any errors. We can also go back to Sketch Front and change the value 240 to 245, for example. And after exiting the sketch, we'll see that it updates correctly. Now we'll take care of the second grip. Unfortunately, there isn't a symmetry or array function yet in the assembly workbench, so we have to do exactly the same thing to constrain the second grip, like the cavemen we are. So, in the toolbar, click on the component icon. In the right-hand menu, click on Grip, use the gizmo to move the part upward, and then click OK to confirm. Next, while holding Ctrl, select the inner face of the grip and then the outermost face of the handlebar, and then click on the fixed join icon. We can see that the grip has been placed upside down. To fix this, go to the right-hand menu and click on the two blue arrows to flip the part, then click OK to confirm. We've now finished assembling the grips onto the handlebar. You can have some fun by going back into the front sketches of the handlebar and changing the values to see if the model reacts dynamically. Normally, you shouldn't encounter any issues. I hope this short tutorial has helped you in your FreeCAD journey. If you enjoyed the video, don't hesitate to like and subscribe, and I'll see you again for new adventures.